So today I'm going to give you an intro to batteries. So what is a battery? Well, a battery is basically a device that converts electrochemical potential into electrical energy. So what is electrochemical potential? Well, electrochemical potential is basically, you could think of it as the potential for an atom of a chemical, like let's say copper, to give electrons to another chemical. And electrical energy is just the energy that you use to power your light bulbs and your fan. And so they basically convert chemical energy or the electricity stored in chemicals. And so Alexander Volta invented the battery in 1800, and he invented it with a famous experiment which I'll be talking about in this video. So there are two major types of batteries: rechargeable and disposable batteries. There are many different types of disposable, including lithium, zinc, alkaline, and much more. We also have many types of rechargeable, including lithium ion, lead acid, and much more. So, fun fact time! Did you know that the word battery comes from the military term battery, which defines a group of weapons working together? So, how do batteries work? Well, a battery basically works with this simple principle. If you have a battery and you have a cathode, which is positively charged, which means that it doesn't have any electrons, and the anode, which has a lot of electrons, as you can see here, and it's negatively charged, and the electrolyte, which blocks the electrons from here to go here. And when you put the wire, the electrons will have a tendency to go across, but because they can't go this way and then they see this circuit, they'll decide to go this way, power the light bulb, and then run here. So what is an anode? Well, an anode is basically the negatively charged side or the side with more electrons. Take zinc for example. It has 2 extra electrons, right? So all the other electrons will never get out of zinc, but these 2 extra electrons, zinc can just push it out. Zinc doesn't need to keep these electrons. And so these are zinc's extra electrons. And then the cathode is the complete opposite. It's supposed to not have as much electrons as the anode is supposed to have. And so in our anode, we can say a cathode, let's say copper. So copper, it has only 1 electron in the outside, unlike zinc, which has 2. So this means that copper has less electrons, which we want. As we see, we have 2. And so if we say copper is our cathode, zinc is our anode, and then we make a battery, all we need to do is take some copper, and in this experiment you all need is a penny, then you need some zinc, or you can take a zinc washer, and then you need some electrolyte. To make an electrolyte, all you need to do is take some paper or cardboard, soak it in some vinegar salt solution, and so then you just put the penny, the vinegar salt solution, zinc washer, and then do that again and again. And then if you put 2 sides of a light bulb, the light bulb should twice a bit switch on. And if you don't have a zinc washer, all you need to do is scratch one side of the penny. Since in 1945, the U.S. Department didn't have enough copper because of World War II. So then they made the copper pennies zinc, but then it was undistinguishable between pennies and dimes. So then they decided to put some copper filing, and these days you'll get pennies with 25% copper, 75% zinc. And so if you scratch one side, you should get the zinc, and then you put the copper side down, as you can see here. Then you put our zinc, and then the zinc side should be up. And then you put electrolytes or zinc. Then you have the electrolyte. Then you have the copper face sitting down on the top, and then the zinc face sitting up. So it should be zinc, cardboard, copper face down, zinc on the top face, cardboard, and then it should keep on. You can just keep on that pattern, and then you should also have a battery. So how does this work? Well, it basically works with this simple concept. So if we have our copper, then our solution, then our zinc, then we have our wire, then we have our electrons, our light bulb, and then this is negative, as we said, zinc is negative, And then copper is now our positive. And so as you can see here, copper has 8 electrons, zinc has 16. Since copper has 8 extra electrons, zinc has 16 extra electrons. Now, since the electrons are all negative, they would want to go to the positive. And when we put this wire, they'll just go across and then switch on the light bulb, and then they will get into the electrolyte. And Alexandra Volta, he didn't use copper, he used silver, but he thought the electrons are going into the silver, not the copper in this case, and not the electrolyte, but it actually goes into the electrolyte. And so now all these electrons, there's 7 more electrons, they're going to go all the way across here and get into the electrolyte. And this is a simplified version. In the real world, zinc would have like about millions of electrons, since these electrons are really small. Okay, fun fact time! Did you know that Americans buy 3 million batteries every year? So, if you have ever had that use a battery and then you just put it inside your toy car and then you just tried making the car move, but then it started beeping and then you just decided to take the battery out, then you realized it was just dead. So all batteries die, and as we saw, our simple sample, when those 7 electrons that we had would go to the copper, then our battery will be dead. And so this is where rechargeable batteries come into play. So rechargeable batteries can be recharged. And so how do rechargeable batteries work? Well, all we need is we have our battery and it's finished. All the electrons went to our electrolyte. And then all we need to do is instead of this light bulb, put this charger. And so the charger is getting charged by electricity. And so then one of the electrons will go around because it'll attract the negative, and then our charger will force the electron out through the zinc. And then all these electrons will do that, and then they will go back to the zinc, which means we have successfully recharged it. Fun fact time! Did you know that the first rechargeable battery, the lead-acid battery, was invented in 1859 by the French physicist Gaston Plante? So I'm going to describe more in depth and how do lithium-ion batteries work. And this is a major battery and what Tesla uses in its electric cars. So lithium-ion batteries. So let me just first introduce you to the lithium. Lithium has a nucleus. It has 3 protons and 3 electrons. Right? So 3 protons and 3 electrons. And two of these electrons are in its first shell, as we saw in zinc. The first shell has 2 electrons, but the second shell has 8 electrons. And since lithium has only 1 electron, it can't fill the whole 8 electron shell. So what it does, it really has a high tendency, so high that if you put lithium in water, it'll just try its best to kick that electron out. So that's lithium. Lithium has a very high tendency, extremely high. And so, in our battery, all we have to do is put a copper plate, which is going to be our negative terminal, and then we put all our lithium atoms inside the copper plate. So we have our electrons, valence electrons, those are the extra electrons that it wants to kick out. And then we have our electrolyte, we have our positive plate, which is the aluminum. And so then all we have to do is so we have these graphite things in our copper plate. So then the lithium atoms don't just go all around the place. And then what we do is we put a wire. And so what happens is our electrons will be attracted to the positive side. So then they will go through the wire and switch on the light bulb. And then because this place will now become negative from these electrons, then the lithium ions, which now don't have 3 electrons, they only have 2 electrons, will also go across. And since lithium really likes to be in another metal like aluminium, and it would like to be in a metal oxide, and so it stays stable. And then all these lithium ions are going to do this same process, and that's how a lithium ion battery works. Thank you for watching. I hope you enjoyed the video. Bye!